Okay, let's talk about another little bit of esoterica here that will actually be useful later on in this chapter. I'm going to entitle this Multiplying Monic Linear Polynomials with Conjugate Constant Terms, okay? Let's go back and recall complex numbers and complex conjugates. You remember complex numbers look like this, a plus bi or a minus bi, where what? A and b were real numbers and I squared is -1, which is saying the same thing we said as I equals the square root of -1, okay? Do you remember if I have a complex number, I find its conjugate by simply changing the sign on the imaginary part. For example here, 3 plus 4i and 3 minus 4i are complex conjugates. I'll just say conjugates. Okay. So a plus bi and a minus bi are complex conjugates. Okay. Now what happens if you have a complex number times its conjugate? Do you remember we showed this in detail? A plus bi times a minus bi turns out to be a positive real number, at least if a and b, either a or b is not 0. Okay, it turned out to be a squared plus b squared. Okay, this is easy to show, I will leave that to you, just by what? Multiplying this out and remembering that I squared is -1. Okay, let's give a quick demonstration of this. If I went 3 plus 4i times 3 minus 4i, we could imagine what? A being 3 and b being 4. Remember, b is a real number. It is not the complex number 4i. b is 4. Okay? So this should be 3 squared plus 4 squared by my formula above. Okay? A positive real number. 9 and 16 is 25. Now that's a quicker way of actually multiplying these complex numbers. This is an important special case, as we shall see as we work our way through this chapter here, dealing with zeros, in fact, complex zeros of real polynomials. Okay, so keep this in mind here. And now the type of problem we're actually going to be running into a little further down the line is multiplying these two monic linear polynomials where you've got the constant term on each of them being complex conjugates. Thus, the title of my page here and the video. Okay, now what if I was to actually multiply these two together? Let's create a formula for that. Well, all we're going to end up doing is basically what? Using the distributive property, or if you want, quote-unquote FOIL. Okay, x multiplies on x gives x squared. Okay, and then x multiplies on this. That's negative a minus bi x. Okay, done multiplying with this x. Now I've got to multiply by this guy, the entire quantity, minus a plus bi. That multiplies first on x here. And we've got that. Now, when these two multiply, don't forget that I get double negative as positive. And then I'm multiplying the complex number a plus bi times its conjugate partner there. Remember, we just mentioned that's the sum of the two squared, a squared plus b squared. Okay, I guess I'll put that in parentheses, but I don't really need to. And now we're almost done here. What I want you guys to notice here is what we've got is x squared minus ax plus bix, okay, minus ax minus bix, okay, plus a squared plus b squared, okay, so that this ends up being, when we combine like terms, x squared minus 2ax, the imaginary terms drop out. Notice they cancel because they have opposite sign, plus a squared plus b squared. Again, you don't need the parentheses if you don't want to. Okay? There it is. Notice that this is a real polynomial, right? A is real and b is real. So every single coefficient in this quadratic polynomial, second degree polynomial, is what? Is a real number. Okay? What is the middle term? It's 2 times, -2 times whatever a is. Okay? Okay, so let's go ahead and take a look on this one. If I was to multiply these two together quickly, I would get the x squared, right? Use the formula. I have negative 3x, negative 3x. You can ignore the imaginaries we set up here. They cancel. Plus, what? 3 squared plus 4 squared. No negatives, no i's, right? That's exactly the calculation we just did here. Okay? In fact, I could have just transferred that there. But let's go like this. X squared minus 6x plus 25. Let's box that in. Okay? There it is. Quick. Very easy. You want to be quick at this. X squared, right? Now I've got what? Minus 5x occurring twice, right? X multiplies on the negative 5 twice. That gives us negative 10. Okay? It's always going to be plus. And then what's my a here? My a is 5, so I'll go 5 squared plus, right? I could have my a being negative 1 and go negative 1 squared, or I could imagine my a being 1. It doesn't matter because I'm squaring, right? So it's going to be 5 squared plus 1 squared. No negatives, no i's in this part, right? There might be negatives over here, but not over here. Okay? Let's finish out the calculation. X squared minus 10x plus 26. And there we go. Okay, one last one here. This one's really easy. X squared. Okay. We're going to get cancellation because you know the a here in each of these is what? 0. So we're actually getting 0 squared plus 1 squared. So this is 0 squared plus 1 squared. This is actually x squared plus 1. You can think of these as what? A factorization of each of these. Okay? So there it is. So you guys get some practice in on those, and we shall get some as we go through and looking at zeros of polynomials. Okay? All right.